Hello, we are back with working on the chain rule, and today we're specifically going to be talking about simplifying within the chain rule. Some of these can get really tricky as chain rule problems are functions within functions, right? They're compositions of functions. So let's look at a quick example here and recall the chain rule when we have a composition of functions. So if we want to take the derivative of f of g of x, right, that would be f prime of g of x times g prime of x. Or if you want to get a little fancier, a little more complicated, what if we have a composition of three functions? Okay, f, g, and h, close, 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 and close. That would be outermost first, f prime of g of h of x times g prime of h of x times h prime of x. That would be our chain rule there. Let's start with a basic example rather than jumping into the simplifying piece. So let's look at a function that we want to take the derivative of, and let's say that function is x plus 1. Let's do x squared plus 1 squared. So in this case, this is a composition of two functions. We could think of this where f of x would be x squared and g of x would be x squared plus 5. So f of g of x, right, if I put the g function into the x value of the f function, I would get x squared plus 5 squared. So let's apply our little rule up here and refresh ourselves on chain rule. So this derivative would then be equal to, well, it says to take f prime. Well, prime is 2. X squared is 2x. 2x, but it says f prime of g of x. So instead of x, I write the x squared plus 5. And of course, that's to the first power. Times, chain rule says multiplication, times the derivative of g of x. Well, g of x is x squared plus 5. So the derivative of x squared plus 5 is 2x. So my final answer would be 4x times x squared plus 5. All right, so that was a quick refresher on the chain rule. We'll now jump into that whole simplifying piece we were talking about. And in order to simplify, we got to have kind of a little bit of a crazy function here, you know? So g of x, we'll say that's something like x cubed. Oh, that was an ugly cube there, a little delay on the board. Times, let's go with the cubed root of 4 minus 2x squared. All right, and we will take the derivative of that clearly, hopefully clearly. This is a product rule problem, so we have f and we have g. And g, when we take the derivative, will require the chain rule. So let's go. Here's f. G prime will be 1/3 4 minus 2x squared to the negative 2/3 times, chain rule says, times negative 4x. So f g prime plus g, which I'm going to be consistent, 4 minus 2x squared to the 1/3, g f prime is 3x squared. All right, so there's our derivative, and now the calculus is actually done. You've done all the derivatives here, okay? At this point, it becomes a simplifying game. I look long and hard, and I see I have x cubed, actually x to the 4th, right? X cubed and x make x to the 4th, and an x squared. So I certainly can take an x squared out of there. I also see I have this little 1/3 and a 3. Well, I can pull a 1/3 out because, well, no, I don't want to do that actually. Scratch that. Oh, look at that, all that stuff that disappeared there. We're not going to pull that 1/3 out. We have our x squared out, and we have 4 minus 2x squared. and the smallest, the lowest power is a negative 2/3. So what I have at this point, x squared came out, so this x to the fourth here becomes an x squared, and we have a negative 4 attached as well, right? So negative 4x squared. I took this entire piece right here out already, right? That's here. Plus, now here, this is interesting. If I am factoring out a negative 2/3, let's do a little sidebar here. If I have x to the fourth plus x cubed plus x squared, I can take an x squared out because that's the lowest power. The question is, how do I get the other exponents? My new exponents, the 4 drops down to a 2, the 3 drops to a 1, and the 2 drops to a 0. So my final answer would be x squared times x squared plus x plus 1. Because we subtracted 4 minus 2 is 2. 3 minus 2 is 1, and 2 minus 2 is 0. So it stands to reason that in this case I'm going to take 1/3 minus negative 2/3, and I'm going to get 4 minus 2x squared to the first power. 1/3 minus a negative 2/3 is a 1. And here the x squared came out, but we still have that 3 sitting there. So we now have x squared. Looks like I have a negative 6x squared and a negative 4x squared. That's a negative 10x squared. Plus 12. All over 4 minus 2x squared to the 2/3. And here you can see we can take out, for instance, like a negative 2. Negative 2x squared times 5x squared plus 6 all over 4 minus 2x squared to the 2/3, or, you know, if you're feeling fancy, negative 2x squared times 5x squared plus 6 over the cubed root of 4 minus 2x squared squared. And that is a simplifying procedure when dealing with the chain rule. I hope these came up already here. See if I highlight them in yellow, if that makes it any brighter. I'm not so sure it did, but I'm going to finish highlighting this here just because I started. I don't like to start something I don't finish. So there we go. We are done with that, and we have concluded our simplifying procedure within the chain rule. Thanks for listening.